ControlNet is a neural network structure that allows adding additional conditional constraints when generating images with diffusion models. Since its release in early 2023, it has become an indispensable part of the diffusion model, SD, Flux ecosystem. With ControlNet, you can generate images that align with the lines, depth, poses, and other attributes of an input image. Flux is currently the most popular diffusion model for generating images, and it has gained strong support from the open-source community. In just over 2 months, multiple organizations have released dozens of different ControlNet models. Although the variety of models is not yet as extensive as those for SD1.5 and SDXL, some of these models work quite well and can be useful in many scenarios. Initially, using ControlNet was a bit tricky since it required installing additional nodes from the model's publisher. However, ComfyUI quickly adapted, and in the latest versions, most models can be applied directly without downloading any additional plugins. Today, I'll cover all aspects of Flux ControlNet, starting from model downloads, installing and using preprocessors, to demonstrating and comparing different Flux ControlNet models in ComfyUI. Finally, we'll test if they can be used with gguf and Schnell models. Let's begin with how to download a model. We'll use the Union model as an example. It supports 7 functions, including pose, depth, and canny. The traditional way is to visit the model release page and download it. On Shaker Labs' homepage, you can see a variety of models they've released. Click See More to find the Flux.1 Dev ControlNet Union Pro, then click to access the release page. You can see that this model was jointly released by Shaker and InstantX. Below is the model card description, some sample images, and examples of how to use the model with code. To download, go to the File and Versions section and download the 6.6 GB diffusion_PyTorch_ model file. Once downloaded, remember to place it in the ComfyUI /models/ControlNet folder. I usually rename it for easier selection. You can also conveniently download models through the ComfyUI Manager. Just click on Model Manager, search for Union, and it will show up. You can click to download it directly to the target folder, very user-friendly. However, this method lacks model descriptions and usage instructions. Also, since the files are usually large, downloading may fail if your internet connection is unstable. Some ControlNet models require specific input formats, such as pose. You can download images from sites like https://openposes.com, but what if you already have a picture of a person and want to copy their pose? That's where the ControlNet preprocessor plugin comes in handy. I recommend using ComfyUI_ControlNet_AUX, which can process images in nearly 50 different ways, extracting their pose, lines, depth, and more. This plugin can be installed via the manager by searching for ControlNet and selecting ComfyUI's ControlNet auxiliary preprocessors. After installation, simply restart ComfyUI to start using it. I'll first run the test workflow provided by the preprocessor plugin. This workflow processes an image with almost all the preprocessors implemented by the plugin, giving us a direct comparison of their effects. Remove this red node, which belongs to the MTB Nodes plugin that I haven't installed. In this case, its purpose is to store run results, but I only need a preview, so I'll skip installing it. Choose a test image, click Run, and the plugin will automatically download all necessary models from Hugging Face. This might take a while the first time. If you encounter this error, it's likely due to network issues. Usually, retrying will solve it. For those who can't access Hugging Face, you can set the HF mirror option when starting ComfyUI. I've finished running it here. These are the depth, lines, colors, and pose information extracted from the original image by the different preprocessors. Let's take a few results under the same line type category as an example. You'll notice differences in line thickness, edge sharpness, noise sensitivity, and shape continuity, so it's essential to select the most appropriate preprocessor depending on the situation. Now, let's see how to use the preprocessors in a workflow. Load an image for demonstration, a nice picture of a lady in a red dress. Add an AIO-AUX preprocessor node, where AIO stands for All-in-One. Open the options to see all the preprocessor types it supports, and choose Canny Edge. The resolution is set to 512 by default, but I'll change it to 1024 since my input image is relatively large, and I want more detailed results. Otherwise, the preprocessor would downscale the image until its shortest side is 512. Click Run. And we get a line drawing. That's how simple it is to use a preprocessor. Next, I'll add a standalone canny edge node. And also set the resolution to 1024. It has 2 additional adjustable parameters compared to the AIO node. During detection, each line has a thickness value. Anything below the low underscore threshold gets removed, anything above the high underscore threshold gets kept, and lines in between are decided by a complex calculation. Click Run. And we get the same line drawing as with the AIO node. Lowering the low underscore threshold to 50 and running again. You can see there are more lines in the result. Now, I'll delete that and use depth, the preprocessor with the most variations in AIO, to see which one works best for this image. I'll add 8 different depth preprocessor nodes and run them. The result from MeshGraph is black because it's designed specifically for hand repair, so we'll ignore it. Out of the remaining 7, I personally think anything V2 gives the best result, clearly distinguishing the foreground from the background, with a well-balanced grayscale range. In addition to the preprocessors within this plugin, we can use any other plugins or models to process images, such as Apple's newly released Depth Pro, which boasts unparalleled clarity and high-frequency detail. In their example image, even a cat's fur is rendered in fine detail. Let's give it a try. Install ComfyUI Depth Pro through the manager. The plugin has very few dependencies, so it's safe to install. Once installed, add a Load Depth Pro model node. You can choose either the FP16 or FP32 model. I didn't notice much difference in my experience, so I'll pick the smaller FP16. Add a Depth Pro node. Connect it. And also add a metric depth to relative node. It has 3 parameters, keep the first 2 as true and set gamma, which adjusts brightness, to its default value of 1. Click Generate, and it will download the model for the first run. The result is impressive. The person is rendered with excellent detail, even down to individual strands of hair, but it couldn't capture the background at all. This might be because my input image was generated by Flux, and the background was slightly blurred. For this input image, Depth Anything V2 provided a better overall result. Adjusting the parameters didn't help either. Here are the results I obtained with the gamma set to 0.1, 0.5, 1, 5, and 10. For those who need to adjust brightness levels, you can tweak it accordingly. Next, let's use the winning depth map from our test and pair it with the Flux Depth ControlNet model to generate an image. I'll load a Flux text-to-image workflow. I already have a pre-saved template that includes all the relevant nodes. All I need to do is select it from the Node Templates section, and it'll be easily loaded into the current workflow, which is very convenient. Unfortunately, the current version still doesn't support saving group information. Now, let's add the ControlNet application process to this workflow. First, add the Load ControlNet model node. I'm using the ControlNet Union Pro model, a collaboration between Shaker and InstantX. This is a 7-in-1 model. Add the SetUnion ControlNet type node and select Depth. Then, add the Apply ControlNet node. Setting the strength to 0.6. With the start and end times from 0 to 0.6. In Flux, parameter selection requires more precision than before, The start time must be early, 0 and 0.01 each have their advantages. However, starting at 0.1 or later can cause the generated image to differ significantly from the reference image. The end time should be at least 0.4 or 0.6. If it ends too early, the control isn't strong enough, but if it goes too late, there's not much change, and it can even affect image quality when generating large images. Strength values between 0.6 and 0.8 are generally good. Based on my comparison, at 0.6, the main subject has already taken shape, and by 0.8, the details closely match the reference image. Personally, I prefer 0.6 to give Flux more room to work. Some ControlNet model types can accept the original image directly, but depth cannot. So, we'll input the result from the Depth Anything v2 preprocessor. To fairly compare the effects of different ControlNet models, it's essential to keep the prompt aligned with the original image to avoid significant differences. I'll reverse engineer the prompt from the original image. Flux has excellent prompt interpretation capabilities, so I no longer rely on WD-14. Instead, I now prefer using advanced vision large language models like MinICV. I'll connect an Allama Vision node. Select the MinICV model, and enter a command that asks it to generate a natural language description of the image. This description will serve as the prompt for the ComfyUI text-to-image generation process. Allama and large language models offer highly practical functionality within ComfyUI. I may create a separate video on this in the future, so I won't go into detail here. After connecting the prompt to the Flux workflow, I'll add a getImageSize node to ensure the generated image matches the original in dimensions. Complete all the connections and click Run. All the nodes perform well, and the generated image is highly similar to the original. To make it easier to compare later, I'll fix the random seed and run the process again. The result looks great this time as well. I remember several depth preprocessors produced good results earlier, but we only used Depth Anything v2. To ensure fairness, let's run them all through the image generation process and compare the results. Duplicate the text-to-image workflow nodes that cannot be shared, and connect different depth maps to each. Apply ControlNet node. Click Run. The results are in, and now we can compare the generated images with their respective depth maps. The choice of preprocessor significantly affects the final output. I still think the Anything v2 preprocessor gives the best result. What do you think? Delete the other preprocessors we won't be using. For the rest of the demo, I'll stick to using Anything v2. As mentioned earlier, different organizations have trained 4 Flux depth ControlNet models based on various datasets. Which one performs best? Let's find out. Add 3 more load ControlNet model nodes to load the Shaker Labs, SLabs, and Jasperi depth models in addition to the Union model. This will allow us to observe if the generated images are similar to the reference when given the same parameters and reference image, and whether the image quality is affected. After running the process, which one do you think did the best? Personally, I think the Union model performed better. Surprisingly, as a multifunction model, its depth results even surpass the pure depth models. If you don't mind its larger size, 6.6G, you can confidently download it. Of course, in real usage, ControlNet isn't meant to perfectly replicate the reference image. It usually helps generate an image that borrows some features from the reference while incorporating your prompt to produce something similar but different. Let's delete the other models and the Allama node. revert the prompt to a text box, and input a prompt about a pink-themed anime girl. Click Run. And here's the result. Although the image has a lot of pink and the girl's face has a bit of a 2.5D look, which is quite different from the original, the position and size of the subject and background, as well as the sense of 3D space, remain consistent with the reference. In summary, among the Flux ControlNet models, depth works very well, and the union model is the best option. Next, let's check out Canny, which is mainly used to detect the edge outlines of objects in an image. The process is similar to depth, just replace the preprocessor with Canny Edge. Keep the model as union, and set the type to Canny in the Set Union ControlNet type node. Leave the prompt and parameters unchanged. And click Generate. The resulting image looks great, with the character's outline closely matching the original image. However, the background is lacking, which makes sense after looking at the preprocessor output. It didn't pick up the background details. Still, despite this flaw, Canny's performance is solid. Like depth, Canny also has several models available, and after testing, Union performs the best. Now, let's look at Pose, which can recognize and control the character's actions and posture, a highly practical ControlNet model. Since the previous reference image was a half-body shot, I'll switch to a full-body image for a better demonstration of the model's functionality. Switch the preprocessor to OpenPose and the model to RALC 0399's OpenPose model, which I find superior to the Union model. Delete the Set Union ControlNet type node. Keep the other parameters unchanged, and run the process. The result is great, and the pose is well copied too. The Union model also includes pose functionality, but its performance isn't as good. Here's a sample image for comparison. However, if you prefer its versatility, you might be willing to compromise on the slightly lower quality. Upscaler is a special type of ControlNet designed for high-resolution image upscaling and detail enhancement. The upscaler model released by Jasper AI performs quite well. Let me demonstrate it for you. First, I'll switch to a smaller image as input. Since this doesn't require a preprocessor, I'll disable the relevant nodes and adjust the node layout. I'll add some math nodes to extract the original image's dimensions, multiply them by 2, and pass them to the empty latent node, effectively increasing the image size by 4 times. This model doesn't need a prompt, so I'll leave that empty. I'll load the upscaler ControlNet model mentioned earlier. Keep the strength at 0.6, but extend the end time to 1. Click Run. And the result is impressive. The upscaling added clarity and detail while keeping it realistic. It might not be as noticeable in ComfyUI, so I'll share a separate image for comparison. You can clearly see that the girl's eyes and lips have become more refined. Let me try it on a painting now, to show the effect more clearly. I'll click Run. The result looks great, doesn't it? The girl with a pearl earring looks refreshed, and her skin has become more detailed. It's similar to popular old photo restoration techniques. Can these ControlNet models work with GGUF models as well as they do with Flux Dev's FP8 format? Absolutely. I'll switch the reference image back to the girl in red and activate the preprocessor node. Still using depth. I'll delete the unnecessary nodes. And restore the original prompt. I'll also use the preloaded GGUF template, adding the GGUF model, clip, and VAE loading nodes. Replacing the current FP8 model. The ControlNet model is set back to union with depth selected. And the end time reverted to 0.6. This way, we're rerunning the previous depth workflow with a GGUF model. Click Run. And the result is nearly identical to using the FP8 model. So if your GPU is struggling with ControlNet, switching to GGUF models is a great alternative. You can refer to my previous video for more details. Currently, most of these ControlNet models are trained on dev models, so using them with the dev model works perfectly. But can they be used with the commercially usable Schnell model? It's a bit tricky, so let me show you. I'll load the Schnell model, provided by ComfyUI. Complete the node connections. And continue using the union depth model. Change the iteration steps to 8, keep the rest of the nodes and parameters unchanged, and click Run. It follows the reference depth map, but the image quality is a bit rough. You might need to retry with different seeds or use in painting to improve it. Some ControlNet models won't generate an image at all with Schnell, so I won't demo those. Hopefully, in the future, there will be ControlNet models specifically for Schnell. Also, keep in mind that these ControlNet models share the same license as the dev model, meaning they aren't commercially usable. Even if you're generating images through Schnell, they're still restricted to non-commercial use. That concludes the demo, so let's summarize. There are quite a few Flux ControlNet models available, with some, especially depth, showing great results. In ComfyUI, ControlNet models can be loaded and applied directly, and the workflows aren't complicated. If your GPU is under pressure, consider using Flux GGUF models. That's it for today's video. See you next time.